Hello everyone again. In Trigonometry 004, I used a unit circle to make a table of points of y values and theta values, both in radians and degrees, and then graph that so you can see what the graph of sine looks like. I even made explanations of how you go about finding the graph of sine of something bigger than 2 pi or a sine of something less than 0. So see that video if you want. Now I'm going to do the same thing, but I'm going to do it for cosine, and then of course the next video will be on y equals tangent. So we're doing the graph of cosine right now, and then next time we'll do the graph of tangent, and then I'll go into some identities. So let's get started. Turn it on my document cam, and we're looking at the unit circle that I made in video 003. What we got to remember is that x is equal to cosine theta, so each of these x values in these points are going to be cosine theta, and that's specifically because the radius, which is the hypotenuse of all the triangles I used, is just equal to 1. So I can just go by and take 0 radians and 0 degrees and say that cosine of 0 is equal to 1, and cosine of pi over 6 is equal to root 3 over 2, and cosine of pi over 4 is root 2 over 2. And just like before, if I want something bigger than 2 pi, I just go 2 pi and say, if I want, for instance, pi over 6 bigger than 2 pi, then that's 12 pi over 6 plus pi over 6. That's 13 pi over 6. So 13 pi over 6 will give me root 3 over 2 for cosine. Similarly, if I want a negative, all I have to do is go in the opposite direction, go clockwise from the positive x-axis. So if I want the cosine, for instance, of negative pi over 6, this is pi over 6, this is negative pi over 6, so root 3 over 2 is the value of cosine at that, and I can continue going on this way. Just got to remember to figure out what the angle is here as opposed to the angle I had marked. So I'm going to do that now using this unit circle. I'm going to fill in the table, which we already filled out for sine. Now I'm going to fill it out for a cosine. So what we found when looking at our unit circle, we found the values of sine for each of these radian angles and for each of these degree angles. So now we're going to do the same thing only for cosine. So we already found that the cosine of 0 corresponds to an angle being 0 radians, which was the point 1, 0, and on our unit circle, x is the value of cosine. So the cosine of 0 is equal to 1. Then the cosine of pi over 6 we saw was root 3 over 2. So that's going to be root 3 over 2. The cosine of pi over 4 was root 2 over 2. So this will be root 2, almost root 3 for some reason, root 2 over 2. The cosine of pi over 3, which is 60 degrees, is 1/2. The cosine of pi over 2, that corresponds to the point 0, 1, so that's actually equal to 0. And I'm starting to see a symmetry as well. I suspect this next one's going to be 1/2, root 2 over 2, root 3 over 2, and 1, and we'll bear that out. 2 pi over 3 gave us next value of negative 1/2, so this is in fact negative 1/2. So we were right, but remember we were at y equals 0, so we should have expected, since we went from a high value, you should have expected a negative. So the values are right, the signs are different. And then if I want the cosine of 3 pi over 4, I look at 3 pi over 4, and I get a next value of negative root 2 over 2, so negative square root 2 over 2. Again, 2 spaces away from the 0, got the same magnitude. And then 3 spaces away should give me root 3 over 2. And sure enough, if you look at 5 pi over 6, you get negative root 3 over 2. And then the next value, of course, we'd expect to be 1. And if you look at pi, the cosine of pi, that corresponds to a point of negative 1, 0. So the x value is the cosine, so negative 1 is the answer. If I continue on, 7 pi over 6, I get negative root 3 over 2. And if I look at, that was 7 pi over 6. Yeah, if I look at 5 pi over 4, I get negative root 2 over 2. Again, as expected from the symmetry. And then if I look at 4 pi over 3, I get negative 1/2. Again, consistent with symmetry. And then finally, if I look at 3 pi over 2, that's the 270 degrees. That's the point 0, negative 1. So the cosine of 3 pi over 2 should be 0. If I continue on, now I expect it to do the same thing it did before. Now we're on the way up, so I should go to 1/2 root 2 over 2, root 3 over 2, and then 1. And sure enough, if you go to 5 pi over 3, which is pi over 6 beyond 3 pi over 2, 5 pi over 3 gives us a value of positive 1/2 for x. And then 7 pi over 4 gives us a value of positive root 2 over 2. And 11 pi over 6 gives us a value of root 3 over 2. And then finally, 2 pi gets us back to the point 1, 0. So we should have a point of 1 for the graph of cosine. So we now have the points. Now all I have to do is plot these on the horizontal axis and these on the vertical axis, and that should make our graph. And again, I'm going to go back to Desmos to show us that. So let me share my screen with you. My screen should be right here. Share that. Switch over to Desmos. There's my sine that I had before. I've actually taken the points off since then, but that's just the actual sine graph. Now, if I want to look at the cosine graph, I'm going to kill this. I'll actually pull it up later because that's going to come in handy for us making some identities. So again, I could plot these points. It would be parentheses 0, 1. That's the first point. The second point is pi over 6, root 3 over 2. Let's see if I can hit pi over 6. Get out from there, comma, root 3 over 2. So I hit square root of 3 over 2. I think you can see by the values that we keep coming up with that the sine and cosine actually have exactly the same shapes. They're just sort of shifted a little bit, because notice when I go from whatever gave me a cosine of 1 to 1/6 of a pi after that, then I immediately jump to root 3 over 2, just like I did with the sine graph. So that tells me the shapes of these graphs, if you just shifted them one way or the other, they would lay perfectly on top of each other. I can do another point. Let's do pi over 4. I'm going to go ahead and copy this so I don't have to continue trying to get a hold of it. It's actually a pain on the calculator, on the Desmos calculator, just because my zoom thing's in front of that button. So I'm doing Control C. So I put a parenthesis, Control V, comma, divided by 4, get out from under there, comma. Then, of course, pi over 4 was root 2 over 2. So I'm going to hit square root of 2, square root 2, get out from under there, divided by 2, close parenthesis, get out from under there first, which I think I can do like this. And then I say divided by 2, and life is golden. So you can see that same sort of shape coming up. Let's do pi over 3 and pi over 2 just to finish it all off. So parenthesis, Control V, over 3, get out from under there, comma, and this one's going to be 1/2, get out from under there, say get out from under there, and then parenthesis, and now I can say parenthesis, Control V, whoa, don't know what happened there, divided by, I would like to know what that was though, because that could be very helpful so I wouldn't have to type this every time, comma, and then this course value is 0. And we see the graph there. Now I can continue putting all these points in, but I think you can see it's going to go from 1 to -1 at pi. Then at 3 pi over 2, it's going to get back to 0, and then it's going to be back to 1 at 2 pi. And it's going to have the same structure where it's root 3 over 2, root 2 over 2, 1/2, 1/2, root 3 over 2, or excuse me, root 2 over 2, root 3 over 2 is 1, -1 in this case, and negatives in all those cases. But we're going to do y equals cosine, and I have to do x here just because that's what Desmos wants. I'm doing theta because that's what I chose for my horizontal axis to be, but I've already got it set up in units of pi, as you can tell. So I'm just going to close this off, and you can now see the graph. And this is, in fact, the next point right here, which would be pi over, these are all supposed to be pi over 6. So this should be pi over 2 plus pi over 6, which would be 3 pi over 6 plus pi over 6 would be 5 pi over 6, which is exactly 1/2. So that should be that value right there. And if you actually click on this, it can give you the points. And 1.88, I think you could find is in fact roughly pi over 6. No, that's not the right one. Maybe it didn't. These units might not be in units of pi over 6, even though that's what I said the steps are supposed to be in. So I didn't check that. But anyways, what our graph for cosine is basically the smallest part where it starts to repeat itself. It starts at theta equals 0 and ends at theta equal 2 pi, just like the sine of x. But the sine of x started at 0, went to 1, went to 0, went to -1, and then went this. So it shifted by like 90 degrees or pi over 2 radians, which I'll show you that in a second. But the main thing is, from this, we can figure out the negatives just like I did before by going in the clockwise direction from the positive x-axis on the unit circle, and then going in increments of pi over 6, you will get this value, and then you'll get this value for negative, and this value for negative. You can see this is what we call, when I was talking about parity and oddness and evenness and all this stuff, this is what we were talking about as being an even function. And what that means is the cosine of, x is equal to the cosine of negative x, whereas the sine of negative x is equal to negative sine of x. So this one's actually a mirror reflection of the negative side, or the negative side is a mirror reflection of the positive side, and that's not the case with sine. So there's what it looks like. I also told you that if you want to go to find out what cosine is for some angle greater than 2 pi, then you just add 2 pi, and then you go ahead 1 more sixth of a pi. When you do that, you'll see that it's 12 pi over 6 for 2 pi, plus pi over 6, so that's 13 pi over 6. So 13 pi over 6 is just going to be the same thing as when you go up to pi over 6, and so on and so forth. So you just add all those, and that gives you all the various functions. You can do the same thing with the negative 2 pi, and so on and so forth. But it's a really beautiful graph. Now I'm going to go ahead and graph sine x on it, so you can see something. Y equals sine of x. Now you can see it's almost like if I took the function or the angle theta, and if I subtracted pi from this angle, so this angle is pi over 2, for instance, right? This angle right here is pi over 2, and on the cosine it corresponds to 0, but on the sine it corresponds to 1. What if I took the actual angle theta and subtracted pi over 2 from it? So if I subtracted pi over 2 from this angle, I would get 0. So if I take the cosine of theta minus pi over 2, or excuse me, if I took the sine of theta minus pi over 2, then when I got to sine of the actual argument pi over, or theta minus pi over 2, I would actually get the cosine. So that gives me an identity automatically. It gives me an identity that says that the sine of theta minus pi over 2 is exactly equal to the cosine. And that's a nice way of thinking about it. But it also makes sense because, remember, the sine gives the opposite over hypotenuse, and the cosine gives the adjacent over hypotenuse. And the opposite and adjacent differ by pi over 2. In other words, if you add the 2, you get pi over 2. So if you do theta minus pi over 2, you're going to get the other theta, the phi. So that's another neat thing about the graphs. It teaches all sorts of good stuff. We can see the max value is 1. You can use your techniques that you learned in basic algebra about if I multiply f of x times 2, what happens to it? Well, it's going to make it 2 units taller. So the magnitude will go from 0 to positive 2 and 0 to negative 2 for the other side. If I multiply it by 2.5, it'll go from negative 2.5 to positive 2.5. I can also multiply the argument inside the sign. I can multiply the theta by 2. That does something different. I can add 4 to the theta inside the argument. All sorts of neat stuff to move these graphs, and we'll discover that later, or discuss that later. But right now, I just wanted to show you how to get the graph of sine and the graph of cosine. So now I'm going to stop sharing my screen, and go back just to remind you, this is the table we found and doing the y equals cosine of theta just by using our unit circle. And you can see I've already got a column drawn for tangent theta, and that's actually an entirely different way. So that'll be our next video. I hope this helps. Have a good day.